after that, your attention span has already expired. Okay, so attention span daw of adults can only last to up to 30 to 45 minutes. And after that, you will not be listening anymore. So maximum of 1 hour lang. And there are going to be, sorry, I apologize for the noise. Okay. So, anyways. So there are three topics that we are going to discuss this evening. So medyo taas-taas siya, because we hope to cover the topics for the first 3 weeks of the semester. Since we started out late, we have to compress the discussion. Anyways, short lang man siya, kay puro description lang man ang atong discuss this evening. So we are going to discuss the topics for week 1, which is the introduction to water resources engineering and hydrologic cycle rather. The second one is on the water code of the Philippines, and the third one is about the rainfall and the runoff. So in this span of 1 hour, no, I hope to have your undivided attention. So only 1 hour, maximum of 1 hour of your attention and your time lang akong pangayoon for tonight, no? So I hope you will listen very well, and the attendance will be checked after the discussion. Okay. So for those who just came in, we have already started quite a while. So we will be officially starting the discussion. So I will now be starting to share my screen. Nasa there. Okay, for a while lang sa I just have to erase. I haven't removed pa man the idea. Okay. So is my screen now visible on your end? Okay, thank you. So, excuse me, sorry. So once again, welcome to Water Resource Engineering. So we will have three, as mentioned kaganiha, we will have three major topics to be discussed. We have for week 1, we are going to have the introduction to hydrologic cycle and the introduction to water resource engineering as well. And the second one is the water code of the Philippines. And the third one would be the rainfall and the runoff. So let us begin with the introduction to water resources engineering. So water resources engineering is an area of professional practice that includes the design of systems to control the quantity, quality, timing, and distribution of water to meet the needs of human habitation and the environment. So aside from the engineering and environmental aspects of water resource systems, their feasibility, no, will also be accounted for, such as legal, economic, financial, political, and social viewpoints must also be considered in the development process. So actually, in dealing with water resources systems, dili lang kay ang engineering design ang atong i-focus, no? We also have to consider the economics and the social factors of the system. So examples of water resource systems include domestic, commercial, and industrial water supply, wastewater treatment, irrigation, drainage, flood control, salinity control, sediment control, pollution abatement, and hydropower generation systems. So in this figure on your right hand side, we have here a bridge. and a dam. Okay, so these are examples of water resources system since they control the quantity of water. Okay, so the waters of the earth are found on land, in the oceans, and in the atmosphere. And the core science of water resources engineering is hydrology. Core science daw of water resources engineering is hydrology. So we know for sure that hydrology deals with the occurrence, distribution, movement, and properties of water on Earth. So engineering hydrologists are primarily concerned with water on land and water in the atmosphere. So from its deposition as atmospheric precipitation to its inflow into the ocean and its vaporization into the atmosphere. So, water resources engineering is commonly regarded as a subdiscipline of civil engineering, and other um, specialty areas are encompassed with the field of water resources engineering. So, for example, the specialty area of groundwater hydrology is concerned with the occurrence and movement of water below the surface of the earth. So, surface water hydrology and climatology are concerned with the occurrence and movement of water above the surface of the earth. So, kibali na siya sa atmosphere. So, hydrogen chemistry is concerned with the chemical changes in water that is in contact with earth materials. So, erosion, sedimentation, and geomorphology, they also affect the quality of our water. So, they are concerned with the effects of sediment transport on landforms, the water policy, economics, and system analysis are concerned with political, economic, and environmental constraints in the design and operation of water resource systems. So, sa akong gibasa, no, water resource engineering is not a standalone field. So, naa siya mga allied fields such as chemistry and hydrology, as well as climatology. And also, water resource engineering would not only deal with water, it would also deal with erosion, sedimentation, and geomorphology. So before we proceed to the other slides, let us first define what is meant by geomorphology. So from the word itself, geo means earth and morph means change. So therefore, water resources engineering is also affected by the changes that is or that are rather happening on earth. Okay? The shaping of the earth. So that will also affect water resource engineering. Okay. Surface water. It has been mentioned more than once in the previous slides. The word surface water. Okay. Surface water pertains to the water that can be seen within and on the surface of the earth. Meaning to say, um, if the water is contained below the surface of the earth, we will now call that as groundwater. So, pero if the body of the water appears to be like this one, like this one, no? Such as rivers, oceans, and streams and lakes, we call them surface water. Okay. Next is the sedimentation. So sedimentation happens when rocks, large rocks, are being weathered, meaning madugmok sila. And if madugmok ang dagko nga bato, syempre naaman ay mga small particles or mga abog-abog. So kanang mga small particles or mga abog-abog, they will be transferred from one place to another. It's either through wind or through water. So in this figure here, we have sediments settling into the river. Kani po kining murag lubog nga part. So these are abog-abog, no, which was carried by the water from one place to another. So in what way does this sedimentation affect our perspectives or perception in terms of water resource engineering. We know nga if water um, moves from one place to another, it carries sediments with it. So meaning to say, kung asa mo agi ang tubig, na ay tendency nga, there is a tendency that its quality will be affected dependent on kung asa siya moagi. Okay? So that's why water resource engineering is concerned with the quality of water because from time to time as water moves within and at the surface of the earth, its quality changes. So aside from the yeah, give the pen. I don't know. Okay. So aside from the sediments that the water can potentially carry, it can also carry with it other contaminants. So the fact gani nga pwede siya mag-carry og mga abog-abog from one place to another, also it can also carry other elements or other components, other chemicals, and other contaminants. So that's why water quality changes. So um, among other many other elements, these are the few of the many elements on earth that will affect the water quality. Okay, so water quality changes because water moves within the earth, and as it moves na siya mga panghapitan. Okay, what if makaagi siya lithium, no? Makaagi siya potassium, makaagi siya rubidium dito, ma-mix siya with cesium. Because we know in the table of elements gani in our chemistry, there are certain chemicals, certain elements there nga that are very reactive with water. So once they get to be in contact with water, there is what we call a chemical reaction. And through that chemical reaction, the quality of the water changes. So the quality of water can be subdivided into two categories, no? The water can be pwede siya mainom or dili siya pwede mainom. So that is the two main category of water, no? Or two ways that we can describe the quality of the water. Okay. So the quantity and the quality of water are inseparable issues in design. Okay, we have the quantity and the quality. So, and the modern practice of water resources engineering demands that we engineers should be technically competent in understanding the physical processes that govern the movement of water, the chemical and biological processes that affect the quality of water, and economic and social considerations that must be taken into account, and also the environmental impacts associated with the construction and operation of water resource. So basically, this summarizes our function as engineers in the field of water resource engineering. Okay, so do you have any questions regarding that? There are none. Okay, so if there are none, let us proceed to the hydrologic cycle. Since in water resources engineering, we are very much particular about the movement of water, no? Kung asa siya moagi, kung unsay sunod niyang agian, no? So, we can learn about how water flows within the earth, no? Through the hydrologic cycle. So, as you have learned in your hydrology, hydrologic cycle is defined as the pathway of water as it moves in its various phases through the atmosphere, to the earth, over and back to land, to the ocean, and back to the atmosphere. Now, by definition, hydrologic cycle now is the pathway of water or agianan niya as it moves in its various phases. Lahi-lahi daw nga phases. So now, who can tell me what are the three major phases that the water will go through during hydrologic cycle? Ilabi, who can give me? Okay, very good. Then Laza, ingon siya, solid, liquid, and gas. So, our water goes through these three different phases, liquid, gas, and solid. So, let us take up that one by one. Okay. So now, from the ocean, we have our oceans here. Since we have our presence of the sun, okay, there is a tendency nga ang mga water droplets diri sa ato ang dagat mo evaporate through the process that we call as evaporation. Now, in this process, in the evaporation process, the water changes from the liquid state to the gaseous state or to the gas state. It becomes now water vapor as it moves pasaka. Okay? So now, there are water vapors nga maipon diri sa babaw. Okay? So, if magsigig evaporate, magsigig saka ang water vapor, na ay tendency nga managhan sila dito sa babaw. So, ang kanang process nga inig kanaghan nila and then managko pod ang mga water vapor dito, we call that condensation. Okay? The water vapor becomes dense. Okay? And magsige kadugay, magkaanan po to kabugat ang mga water vapor dito. So, and then if mabugat na sila balik, ma-attain na nila ang specific weight nga ma-affect sa gravity sa Earth, they will fall back to the Earth through our rainfall. So we call this process from the water vapor from gaseous state to the liquid state, we call that precipitation. Okay? Or in some other non-tropical countries, they experience snowfall. So from the rainfall, if the temperature is very, very low, there is a tendency that the water vapor freezes. So that's why in that case, our water takes from a liquid form to the solid form here. It will fall back to the earth through snowfall. And then when snowfall falls back to the earth, it melts. It now becomes in its liquid state. So ang kanang snow melt, padulong na siya sa surface water, mo-flow na siya, balik kay gyapon na siya sa ocean. Now, ang katong ulan po nato para diri sa Pilipinas, it's either moadto na siya sa mga surface water or moadto na siya sa mga punuan or mga tanom or moadto na siya sa atong mga buildings in urban areas. Pero ang uban ana, it's either mosunop sila sa yuta or just surface runoff and then go back to the ocean. No? Balik ra gyapon na siya dito. And then from the ocean, it will start to evaporate once again, and then the water vapor gets to be condensed, and then the hydrologic cycle continues. Okay? Do you have any questions regarding that? None. All right. So to proceed, okay. So we know that in hydrologic cycle, the water moves no from one place to another and all throughout the earth. That means to say naagi na siya mga makerry nga mga contaminants. So unsa man ang mga contaminants ang madala no? For example, mag-ulan lugar and then ang ulan is ni-occur siya sa stayag. So stayag is a coal-fired power plant. So they process ores, or they have what we call as the coal fly ash, kana nga industry. So if maulan na dito sa stayag, syempre ang tubig mamix din na siya with the coal fly ash. So karon after sa ulan, moagi siya sa stayag, Inigawas ana didto from the stayag, nagdala na to siya og coal fly ash. Okay? So that is how the quality of the water changes. So we have different types of contaminants, no, for our water. We have plant and animal material which can be classified as oxygen demanding waste, no? Or hugaw. For example, kanang hugaw sa dalan, hugaw sa iro sa dalan. Syempre, ang tubig sa ulan nga masagol dito sa hugaw mo fall back to the drainage, but the water nga niadto sa drainage nasagulan na to siya og um, animal material. Okay? Also, bacteria and viruses, which can be classified as infectious agents. Also, if mag-ulan, syempre maulanan namin nato ang mga tanom nga saging, and atong mga saging namin mga fertilizers. So, atong tubig diha nga part makadala gid siya og mga fertilizers or plant nutrients. Also, pesticides, no? Iron from steel plants, clay silt, and waste products, and also heat from the industry. So these are the different types of contaminants that will affect the quality of the water. Okay. Okay. So that was ang uban dani nga uban ani nga slides. I have presented data. So I will not be taking up this one by one because I think dili siya maklaro pod in your screens. But I will be providing you man with this lecture notes so you can review later on. Okay. So that was about the hydrologic cycle. Let us go directly to here. Water Code of the Philippines. So I will not be talking about what is stipulated word for word in the Water Code of the Philippines. Instead, I will be talking about the purpose, no? Unsay benefits para asa or unsa ang Water Code of the Philippines. Okay. So I have here I think five. So first, the Water Code of the Philippines is for the declaration of policy. So the Water Code of the Philippines aims to provide for the utilization and conservation of water resources to ensure their sustainable management. So from the word itself, sustainable. So since water is a natural resource, we do not want it to run out. No? So dapat kung naitubig karon in the future generations, naagya po'y tubig no na magamit. Okay. The second purpose of the Water Code of the Philippines is the ownership, no, of water resources. So water resources are considered a national patrimony owned by the state. So private ownership of water is generally not allowed. Okay, so isa ra gyud ang gatag iya sa tubig diri sa Pilipinas. Ang government ra gyud. Okay? Okay. So Water Code of the Philippines is also for permit system. So code establishes a permit system for the use of water resources. So requiring permits for various activities such as water appropriation, water quality management, and construction of water-related infrastructure. So dili lang pod pwede nga basta-basta lang, no? Mahimo tag activities or mo construct tag water resources systems for our water related activities or purposes. We have to secure a permit for that. Okay. So Water Code of the Philippines is also to maintain water quality standards. So Water Code of the Philippines sets standards for water quality. So in that way, it is to protect human health and the environment. Okay. Protection of watershed is also one of the purpose of the water code. So the code emphasizes rather the importance of protecting watersheds to maintain the quality and quantity of water resource. So this word watershed, you will be defining this one in a while. Okay. So, Water Code of the Philippines is also for the irrigation and agriculture of the country. So, it promotes the development of irrigation systems to support agricultural activities. So, we know irrigation is for the benefit of our farmers and other agricultural products. Okay. Water Code of the Philippines also is for the flood control and drainage. So the code addresses flood control and drainage issues, allowing for the construction of flood control structures. Sa kanang ato ang mga dike, mga bridge, no? They are covered by the Water Code of the Philippines. Also, Water Code of the Philippines is for the environmental protection. So, there are provisions in the code that is specifically to safeguard aquatic ecosystems and the environment in general. Okay. And penalties na dayon. So, failure to comply to the provisions of the code will impose penalties. Okay. Okay. So let us have real life applications or examples of the purpose of the Water Code of the Philippines, no? So for water permit for a bottled water company such as Nature Spring, no, for example. So when a bottled water company plans to extract water from a natural source for commercial purposes, they must obtain a water permit in accordance with the Water Code. So this ensures that water resources are used sustainably and that water quality is maintained. So also, watershed protection. Ang kaning watershed protection is basically any part sa earth nga pwede agian sa tubig. Okay? So such as our rainforests, mga ana no, na nang mo naturally flow gani ang tubig. Ato mga kagubatan and everything, ganun. So, local governments and environmental organizations, they often engage in watershed protection projects and activities to prevent deforestation and soil erosion. So, these efforts are aligned with the Water Code's emphasis on safeguarding watersheds to protect water quality and quantity. Okay. So as I've mentioned kaganihan no in the first slide, so ang purpose pod sa water code is for flood control projects such as this bridge and this dam. Okay. And also for our irrigation system development. So ang water code of the Philippines naapod siya para mag-guide no kung unsaon paghatag og patubig sa atoang mga farmers. Okay? Okay. And water quality monitoring also, since this is concerning the public health, no? Aside from the water that we drink, which concerns the public health, ang kana pong mga tubig sa sapa, tubig sa dagat, atong mga dagat, atong mga suba diri as Cagayan or even in the Philippines, kanang mga coastal cleanup gani. So, they are also governed by the water code. So these examples demonstrate how the water code in the Philippines plays a crucial role in regulating and managing water resources from commercial water extraction to environmental conservation and disaster mitigation. So those were about the water code of the Philippines. Do you have any questions regarding that before we proceed? Okay. So if there are none, let us proceed to the last topic for this evening, which is on runoff and rainfall. So anyone from the class can give me what comes to your mind when you hear the word runoff or water runoff or surface runoff? Sige daw, anyone?
Baha is
Very good observation. Wait. Okay. Water above. Hmm, what happened? Okay. Can you still hear me?
Yes, ma'am.
Okay, thank you. So, surface runoff means baha or okay, water above the surface of the earth or it is the excess water. Okay, that's very good. So, kabulo naman na mo. Pinata mag-discuss, Charis. Okay. So, water runoff or surface runoff is baha or excess amount of water na na-absorb sa yuta. Tama ba? Heart daw, B? Kung tama ba? Okay. So now, since we have already defined what is a surface runoff, now if I may ask anyone also, where does the surface runoff come from? Siya gikan. Sige daw. Siya gikan. Precipitation. Okay, that's very good. So precipitation means the falling back of water from the atmosphere to the surface of the earth. So that means to say, surface runoff is coming from the rainfall, okay, or from precipitation. So therefore, before we proceed to the discussion of the runoff, let us talk about the rainfall. Kaya dili magid ang punot dulo sa runoff. Okay. So, surface water hydrology is the science that encompasses the distribution, movement, and properties of natural water from the surface of the earth. So, applications of surface water hydrology in engineering practice are mostly encompassed with the field of engineering hydrology, which includes modeling rainfall events and predicting the quantity and the quality of the resulting surface runoff. Okay. So, before we proceed, natay duha ka word diri nga i-define, no? We have here the watershed and the catchment area. So, ang watershed is the potential land area, no? Kung asa pwede mo flow ang water naturally. So, basically, this is everywhere on Earth. Kaya pwede man ta maagian sa tubig anywhere if we want, no? Even if we don't like the such as our rainforests, no, our mountains, may na, no. So any part of the earth na kung asa pwede mo naturally flow ang water, we call that watershed. However, we have also another word, no, that is interchangeably used with watershed. We have the catchment area. So ang catchment area is particular area is an area in the watershed over which a particular rainfall event no could potentially happen. So ang DI, if we mean to say watershed, dako siyang area, ang catchment area is a part of the watershed kung asa pwede ulanon. Okay. Since we cannot predict man kung asa nga part sa earth ang ulanon, we can consider the whole watershed to be a catchment area. It doesn't mean nga unlike for the deserts no na dili man gyud siya potentially ulan. But in other places, the watershed can also be referred to as the catchment area. Okay? So watershed and catchment area. They are two different words, pero they in a common sense no, pwede sila synonymous. Okay? So, the precipitation of water vapor from the atmosphere occurs in many forms. So, the most important of which, as we have mentioned kaganiha, we have the rain and the snow. Pero the uncommon ones are the hail and the sleet, no? Since we are a tropical country, we do not experience this one. So, engineered drainage systems in most urban communities are designed primarily to control the runoff from the rainfall. Okay. So, that's why ang ato agi daw when it talks in the context of urban communities kani mga syudad-syudad lang na consideration. Mainly, ang ato ang gina-design diri is drainage system. Oops, sorry. to control runoff from the rainfall. Basically, because in the case of DPWH and the local government unit, as you can see, no, namang yung mga construction of pipe culverts, box culverts. So those are drainage systems, no, that are designed to control runoff from the rainfall. Okay. So since we are very much concerned, we Okay, we engineers, we are very much concerned about the runoff because of the risk of having a flood, right? So we know that runoff comes from the rainfall. So now, as engineers, we have to investigate kano sa amang gidi ay mahitabo, no, ang rainfall, so that we can predict when will there be a rainfall, because when there will be a rainfall and the excess water from that will become runoff. So that is now where our problem begins. So rainfall happens when there is a cooling of the air mass, meaning there is a change in temperature. So from init to bugnaw, there's a tendency nga muulan. Okay? Also, there is a condensation of water droplets onto the nuclei. So kung mag-condense gani ang water vapor dito sa babaw, and then sobra na sila, there is a tendency for a rainfall to happen. Okay? And if there is also a growth of water droplets, napoy tendency nga mo rainfall. And other mechanisms to cause a sufficient density of droplets for the precipitation to fall back to the ground. So, bantayan na ning upat ka factors, kay if any of this, any one or two of this, exist, dakog possibility for the rainfall. Okay. So, since we engineers, we design drainage systems and water resources systems to address and to combat, no, to control runoff, which comes from the water, rainfall, or no, which comes from the water from the rainfall. So, since for more than 2,000 years now, the rainfall, the intensity of the rainfall have always been collected. Gina-record nato ang intensity sa rainfall, unsa siya kakusog, no, or the volume of the rainfall, unsa siya kadaghan. Because kung daghan rainfall, daghan runoff. Kung gamay ra ang rainfall, gamay ra pod ang runoff. Therefore, the volume for the runoff is directly proportional to the rainfall. That is why we engineers, we cannot directly calculate the runoff alone. We have to calculate the rainfall first. Okay? So in calculating our rainfall, there have been a lot of inventions naman in on how we can measure the rainfall. Now we have automatic recording gauges and non-recording gauges. So ang butas-abot lang ana, there are automatic gauges nga mo record lang siya, mo lang siyang i-display dadto, mo record na siya. And non-recording is data lang yung kwaon, then all you have to do is compute pa dayon for the rainfall data. Okay? So either way, you can still solve, or you can still determine, or you can still measure the rainfall intensity. Okay? And then from that, if you are able to compute na the rainfall, then it would be easier for you to anticipate the volume of the runoff. And then that is where na dayon you can decide, or you can start with the design of your drainage system. Okay. So now, since we have already defined the rainfall, which is where our runoff comes from, let us now define what is a runoff. So a runoff can be defined as the portion of the precipitation that makes its way towards the rivers and the ocean as surface or subsurface flow. So ang runoff, as shared kaganihan, no, by Joe. Yeah. So that is a very good answer. Meaning to say, ang kaning runoff is ang amount of water nga wala na nakaya og sunog sa yuta. Nagpabilin na lang siya sa surface. And then since water will always find its way out, no, na itaas ng elevation, na iubos ng elevation, water will always flow. And water, no, will flow back to the other surface water, such as the ocean. Okay? So, mo to siya now, runoff occurs only when the rate of precipitation exceeds the rate at which water may infiltrate into the soil. Okay. Okay. So, what are the things that affect the runoff? Okay. We have here. Ay, what happened? Okay. First one is the climatic factors. So, climatic factors, kung ting-ulan or ting-init. So, kung ting-ulan, may possibility for runoff. Kung ting-init, syempre wala. Okay? Another factor is the rain and the snowfall. So, of course, if there is a rain, there could be a runoff. Kung wala rain, di wala po yung runoff. And of course, another factor is rainfall intensity, kung unsa ka kusog ang ulan. So, kung kusog ulan, kusog runoff. Kung hinay ulan, hinay po runoff. Okay? Also, the rainfall duration, kung unsa kadugay ang ulan. Syempre, kung dugay ang ulan, daghan surface water, daghan runoff. Okay? Kung kadyot ra pud ang ulan, gamay ra pud ang tubig, basig di ay kaya ra sa yuta i-absorb ang water, dili na siya mo overflow in the form of surface water. Also, rainfall distribution. Kung dako nga part sa lugar ang giulan, dakong probability for runoff. Kung gamay lang, isa ra ka barangay ang giulan, then gamay ra pud ang runoff. And also, the physiographic feature and the shape of the watershed. Okay. For example, ang isa ka lugar is bundok siya, no? So, ang possible flow ana sa water is from high to low man yun. So, if dakog differential elevation from high to low, kusog ang runoff. Kung flat lang siya, hinay ra pud ang runoff. So, ana, no? And also, the soil moisture content. Okay, since ang mag-dictate sa surface water is ang capacity man sa yuta to absorb water. So, kung ang yuta is basa na daan, meaning gamay na lang ang iyahang pwede masunog. Okay, in that case, daghan gyud surface water. Whereas if the soil moisture content is low, meaning uga-uga ang yuta, mas daghan pa siya masunog nga tubig, therefore reducing the surface water. Okay? So those are the factors affecting the runoff. Now, let us elaborate through this figure here how runoff moves, no, in the surface of the earth. Okay, so from the I will be highlighting here what is meant by the watershed. Kaning red. Okay. So for example, kani arang watershed boundary, kani ratong i-consider ng area kung asa pwede mo flow ang water. Okay? For example, we have the catchment area din here, which is the blue part. Aning blue part, maura ni siya ang ulanon. That is the catchment area now. Okay. So inig ulan, the water will move, will go back to the surface of the earth dinhi, then move dayon siya sa watershed. Okay? Mag-flow lang siya diha. Flow. So ang uban, moadto sa ground, no? Mo penetrate. Okay? Then balik dayon sa dagat. Okay? Mubalik sila sa dagat. Dito sila moagi sa ilalom. Okay? So now, ang uban, if di na makayag sunok, dito ra sa surface. So that is the surface runoff now. Now the surface runoff will flow back gyapon sa ocean. Okay. So that's why we have two different major kinds of runoff. We have the surface runoff and the subsurface runoff. So ang surface runoff is katong water nga sa surface ra gyud siya niagi, wa gyud siya kasunop. Pero there is a tendency man pod for the water to penetrate, although penetrate siya dire, penetrate siya, pero dili ra gyapon siya ka adto sa ilalom gyud nga part sa yuta. Mo penetrate siya kadyot, pero mobalik ra gyapon siya dito sa oceans. Okay? So that is what we call as the surface and the subsurface runoff. Okay? So that is all for the runoff and the rainfall. Do you have any questions and clarifications? None. Okay, so nasabtan lugar. Okay. Anyways, asa man ko? Wala lagi kay camera. Wala kay camera, no? Okay, what happened? Okay, anyways. Di na ako mag-camera. Okay. So, I will not be checking your attendance. Okay, thank you. Please say present if you are here. Oops. This one. By the way, on Saturday, we will not meet, ha? I will see you all next week. I hope it is fine. Okay na ba? Okay. Abaw,
Present, ma'am.
Aboy Natilia, wala. Baguio, Erica Jane,
Present, ma'am.
Bobadilla,
Present, ma'am.
Cabana, Kabilaw, Joshua, Kahintong, Ma'am present. Okay. Kalagsing,
Present, ma'am. Good evening.
good evening. Kalipayan,
Present, ma'am.
Cantero Jo, present.
Present, ma'am.
Okay. Dalis,
Present, ma'am.
okay. De Los Santos, Sebastian,
Present, ma'am. Present, ma'am.
okay. Deloso, Desiree,
Present, ma'am. Good evening.
Denlaza,
Present, ma'am. Good evening.
Dumanag,
Present, ma'am. Good evening.
Durano,
Present, ma'am.
Lanzaderas.
Present, ma'am. Good evening.
How are you related to Brian? Lanzaderas.
Wala ra ba? Wala, ma'am.
Okay lang. Okay. Laroga, Josephine Marie,
Present, ma'am. Good evening.
Lucero, Rica May,
Present, ma'am.
Lungay, Shania.
Good evening, ma'am. Present po.
Okay. Makula, Reggie,
Present, ma'am.
Mata, Alexander.
Present, ma'am. Good evening.
Okay. Merdas, Naji Kent.
Good evening, ma'am. Present.
Okay. Nisperos, Paul Vance.
Present, ma'am.
Raniesas, Jovi.
Present, ma'am.
Ribalde, Junriel. Wala. Sultan, Narisa.
Good evening.
Okay. Tagod, Estelle. Wala. Tambis, Jomar.
Present, ma'am.
Texon, France.
Present, ma'am.
Chu Contreras.
Present, ma'am.
Toquero, Lovelane.
Present, ma'am.
Tuwal.
Present, ma'am.
Ukab, Jeanette.
Present, ma'am.
Valiespin, Kathleen.
Present, ma'am.
Velas, Kathy.
Present, ma'am.
Villanueva, Ren.
Present, ma'am.
Ibanez, Kim Harold.
Present, ma'am.
Ibanez, Maylene.
Present, ma'am.
And Zaya, Cyrone.
Present, ma'am.
Okay, thank you. Si Angelica Bana.